see the necessary conditions for a to the power of m over n being equal to a to the power of 1 over n the power of m, which is also equal to a to the power of m the power of 1 over n. So to do that, let's consider the following two expressions. So the first one, what's the square root of 81? So we want to find the real number that we can multiply twice to get 81, and then the real number is 9. But minus 9 also squares to 81. So how do we resolve that? Well, we define the principal nth root of a positive real number to be another positive real number that we can multiply n times to get the original real number. So the principal square root of 81 is defined to be 9, not minus 9. So that's the first one. So what about the square root of minus 36? Well, we want to find a real number that we can multiply twice to get minus 36. But is there a real number that squares to a negative real number? Well, there isn't. So this is not a real number. Okay? So let's look at the first two necessary conditions. The first one, as you may have guessed, is since we can't divide by 0, is that n has to be different from 0. And the second condition is that a to the power of 1 over n is a real number. And a to the power of 1 over n is not a real number when a, which is also called the base, is less than 0 and n is even. Okay, so let's see this example. What is the square root of x squared? Well, we know that for this to be a real number, the base x squared has to be greater than or equal to 0, which it is, and we defined the principal nth root of a positive real number to be another a positive real number, which we can multiply n times to get back the original real number. So this is not simply x, but absolute value of x. So again, so the base has to be greater than or equal to 0. And for a positive real number, the principal nth root is defined to be another positive real number. So we have to guarantee that the solution is positive, and we do that using the absolute value. Okay, so let's consider the following. So x is equal to x to the power of 1, okay, but 1 is also equal to 2 over 2, so we can say, well, this is equal to x squared the power of 1/2, so we get two contradictory solutions. So how do we resolve this? So we resolve this by adding a third necessary condition, and that is we can only make such an expression if m over n is a fraction in lowest terms, and that means m over n cannot be simplified further. For instance, 2 over 2 is not a fraction in lowest terms because we can simplify it to 1, and if m over n is a fraction in lowest terms, then we can say a to the power of m over n is equal to a to the power of 1 over n the power of m, which is also equal to a to the power of m the power of 1 over n. So the first condition, where n has to be different from 0 and m over n being a fraction in lowest terms, is something acceptable. But maybe you may have a question with regards to, if we define the square root of -1 to be I, will the second condition be necessary? So let's look at an example. So let's consider -2 to the power of 3 over 2. So we know that from the second condition, since the square root of -2 is not a real number, that we cannot say -2 to the power of 3 over 2 is equal to -2 to the power of 3, the power of 1 over 2, or -2 to the power of 1 over 2 the power of 3. So, but let's show the contradiction, and here we will define the square root of -1 to be I. So we will introduce imaginary numbers. So minus 2 to the power of 3 over 2 is equal to, well, we have a problem with a negative base, so, well, let's multiply, let's distribute the 3 over 2 power to minus 1 and 2, so we have 2 to the power of 3 over 2 times minus 1 the power of 3, the power of 1 over 2. So here we decide first to take this the third power, then follow that by taking the square root, okay? Then which this is also equal to the power of 3 over 2, and minus 1 cube is minus 1, and square root of minus 1, we define it to be I, so this is equal to 2 to the power of 3 over 2i. But however, if instead of taking the third power first, we decide to take the square root first and take the third power next, we see a contradiction. So let's see that. So if we instead take the square root first, then followed up by taking the third power, we have 2 to the power of 3 over 2 times the square root of minus 1, the power of 3. The square root of minus 1 is defined to be I, so we have 2 to the power of 3 over 2 times I cube, and I cube is I times I times I, and the first two i's will give us minus 1, by the definition, and we have one I remaining, so we have I cube gives us minus I. So we see that the two answers that we have contradict. So the second condition is indeed a necessary condition, even if we introduce I, which is square root of minus 1. I hope you enjoyed it. Thank you.